Hello everyone, my name is Dr. Ammar Bahman. I'm a faculty member at the Mechanical Engineering Department at Kuwait University. Today I'm going to talk about my poster entitled Investigation of Variable Speed Residential Heat Pump Unit with Expansion Work Recovery Device. This work was in collaboration with a research team from Purdue University. Well, basically due to the environmental growing concern over the climate change is the driving motivation for this work. Given that in 2019, around 40% of Kuwait energy consumption was associated in buildings, and 70% of that energy is contributed to HVAC and AC system in particular. So any significant improvement in the AC system will eventually enhance or increase the energy saving of the whole country. In this work, we basically want to utilize the energy loss or heat loss in the expander in the AC system. Here we notice that there is a tremendous amount of heat loss in the expansion, so we try to harvest that heat and convert that heat into electric power. Eventually we can increase the overall efficiency of the system. So our expander, our design expander, is basically consists of a nozzle and a turbine, where we try to inject the refrigerant coming out of the condenser in the liquid form into the turbine. So we have two-phase output coming out. The liquid goes to the evaporator, so we're flooding the evaporator. At the same time, the gas is bypassed into the exit of the evaporator. So as we inject refrigerant through the nozzle to the turbine rotates and we can harvest the electric energy generated from this expander. Well, the objective, or the main objective of this work, was to develop a model that can simulate this cycle, including the expander. So we worked on a detailed model that deal with the individual components and the geometry and the charge imposed into the system. So as you can see, what happened in the model, you entered all the input parameters, the working condition, the detailed geometry of the system. Then it goes in sequence through the different component of the system, starting from the accumulator model, suction line model, then compressor, discharge line, condenser. It's good to mention that this model also, it's very detailed, that also takes the pipelines and the details of the pipelines. So after the discharge model, the information goes to the condenser model, liquid line model, expander models. So this is basically the detailed model which we worked on, evaporator model, and finally the charge model. And it's checked for the saturation temperature. If it's satisfied, it converts. Otherwise, the model keep iterating. So we compared our results, our model results, with the experimental work. We saw that the model was quite accurate, and the results was observed within 10% range of accuracy. Once the charge model was implemented, we were able to predict the charge of the system to less than 1%. So this model was quite accurate. In summary, the system model was predicted within very quite accurate range of error. The charge imposed model estimated the error within less than 1%. The detailed model has the potential to allow us to examine drop-in refrigerant such as natural refrigerant or flammable refrigerant for sustainable systems. In the end, I'd like to thank the research sector for sponsoring this project. Thank you.